We just started section 4.1 yesterday, and we, I think, covered this example to explain what an inverse function means, what does it actually do. So basically, in real life or in math, there are some functions that convert domain into range values, such as domain is your dollars in your pocket, range is euros. $100 change into 80 euros. So it goes from left to right, but sometimes you need to change back. You want to do undo actually what you earlier did, and you want to convert from euro to dollars. And for this, you need a brand new function for that change, and you obtain that brand new function from the old one. I will show you the procedure later today, and this can be computed from this old one, and that actually does whatever f do earlier. Okay, so basically it flips range and domain values. Instead of 100 going to 80, now 80 going to 100. Okay, and when we take a look at the graphs of these functions, the original one is blue. The new one you just created is actually just the symmetry of the blue one across this dashed line, which is y equals x. Okay? Any questions so far? Alright. What other properties inverse functions show is one-to-oneness. First one is called one-to-oneness. We need to first learn about this. Inverse, first of all, not every operation can be reversed. I mean, not all functions are invertible. Sometimes you may not find inverse of some functions. To be able to invert a function, one property we must have is one-to-oneness. For example, let's take a look at this example. I want to associate this example to yesterday's example. Like, you go to the bank and you want to change $1 into, let's say, let's choose another currency. Like, what's the other currency you know? Give me a currency other than euros. Pesos, right? So $1. So you go to bank and they you hand them over $2, and the banker gives you back, okay, this is $3, 3 pesos. Here is your 3 pesos. Okay, and then you change your mind. You just come back and say, oh, here is your 3 pesos back. You hand this over to the banker, and the banker gives you this time $1 back. And you say, what the heck? I gave you $2 a minute ago. Why are you giving me $1 back? And he just shows, oh, my computer says $3 is equivalent to 1 this time. And you say, but earlier I gave you $2 for 3. So what's the situation here? The situation here is there is the same value y for 2 different dollars amount. So 2 x values are going to the same y value, and when you need to undo what you did earlier, the banker is kind of confused. Oh, there are 2 amounts, I should go with the lower one because I don't want to lose money, right? So if such a case happens, we call these functions not invertible. It's not one-to-one, so you cannot find inverse. Okay? So another example might be there are 2 passengers here, passenger 1 and passenger 2. They both get out of the bus at 3rd Street. When you go back to pick them back up again, you go back to 3rd Street and you want to bring them back home, you're confused which address was number guy was living or number 2 was living, because they both got out of the bus at the 3rd Street, right? You don't know where to take them back. But here, you do know where to take each back, because each dot is distinct. They went to the different addresses. Like this guy went to 80, this guy went to, what was this value? Whatever it was. And this guy went to 160, so you know where to take them back. This goes to 200, this goes to 100, and this goes to 250, okay? So this point is lined up in different heights or y values. We call it one-to-oneness in loose definition. But the real definition is, this is the formal definition we are going to employ in some questions. Please pay attention here. If two guys go to the same address, these are the locations they went, these are y values. If their y values match, if the y values of two different people match, actually those two guys were not different at all. They are the same guys. They should be the same. So it's saying that no two different guys cannot go to the same address. Their addresses must change. So there are two definitions here. However, we will not be using the left side. This is the side we will be using in problems. Okay? If y values match, then x's must be the same. A and B are not two different guys. Okay? Alright. If you're lucky enough to be given the graph of a function like this, or this one, or that one, you can employ a test. It's called horizontal line test. Wait a second. Earlier in this course, in a section before this, we have seen a line test before, right? What was that line test called? Vertical line test. This is horizontal one. What was vertical line test for? It's to check what? If whether the graph belongs to a function. And if two points line up on the same vertical line, then we call it's not a function. Here we are using horizontal line tests, and whenever you catch two values lined up on the same horizontal straight line, then we call this function not one-to-one. So this is a not, this is my shortcut to say one-to-one. 1, 2, 1. This is not one-to-one. How about this guy? Let's pass a horizontal line through these points. Single touch, single touch, single touch. Almost. Okay, so three lines never intersect another point, more than one point. So this is good. This is a one-to-one function. Okay, again, not one-to-one because two dots lined up on the same straight line. Any questions so far? So to check whether a function is invertible, you can undo what that function does is one-to-oneness. You need to first check one-to-oneness and then go invert it if possible. Alright, we are gonna first exercise on this. There are two problems on your homework set about one-to-oneness. Just decide, think as passengers if you like, or think like dollar to pesos change. You have passenger -9 going to -5, address -5, passenger 2 going to address 4, passenger -8 to going to 4, 8 going to 5. Is this a one-to-one relation or function? Is it one-to-one? Okay, there are various ways you can do this. If you like, plot how many points? This is not too bad. 4 points. Plot them and do horizontal line test. -9, -5 is somewhere here. 2, 4 is here. -8, 4 is here. 8, 5 is here. No, 8, 5 is not there. 8 is here. 5 is there. Does this thing look like one-to-one? Why? Yeah, 2, 4 and -8, 4 are both on the same line. There we go. Violation. It's not one-to-one. There is another way to test. You could actually say here, if two y values showing up at the same time, not one-to-one. Look, the y values are the same, but x's are different. This cannot happen according to this. If y values match, those x values should match as well. These 2 points 2 and minus 8 cannot happen. This is a direct approach. Some people like to do Venn diagrams. They line up x values here, minus 9, 2, minus 8, and 8. These are x's. Y's are minus 5, 4, and 5. And obviously you see 2 is going to 4, minus 8 is going to 4. I mean, two different people going to the same address. It's a function. It can happen. You can go to the same address, two different people. But this is not one-to-one because you don't know when you're coming back from 4, you don't know who's going what address. Okay? Alright? So no two arrows can go to the same place. Alright, is this one-to-one? Alright, let's check. Are there any matching values on Y? Different, 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 different. One-to-one. Okay? You can just show arrows, all single unique arrows. If you like, you can plot these points, okay? But it's time consuming. Alright, I think we got it, right? Let's do some couple of them on graphs. Which one of these graphs are one-to-one? Which one are not? Number 3, 4, 5. This one, left side. One-to-one or not? Yes. Let's show a couple of test lines. All single touch, right? Okay, how about this one? It's a no because how many touches does it make? 1, 2, 3. 3 different x values such as 2.5, 1, and -4 are going to the same address. Impossible. It's a function though. Function, but not one-to-one. It's not a one-to-one function. You cannot find inverse of it. Alright, how about this one? Is this a one-to-one function? Ashley? No? Yeah. Yes? Kylie? It's a one-to-one? Yeah. Madison?
It's one-to-one, but it's not a function.
Maddie? No, which one is Maddie? You're Maddie, right?
Yeah.
Madison? No, Courtney. Courtney, right? Yes? One-to-one? Okay. One-to-one function. Let's okay, one-to-one function. Kyle? One-to-one function. Alright. If I say one-to-one, I'm right. But if I say one-to-one function, I'm wrong. And one-to-one cannot be used single. It's two words together, one-to-one function. Okay, so we are testing here whether this thing is one-to-one function. The answer is no, not one-to-one function. Why? You may wonder why. It looks like it passes horizontal line test. It's kind of one-to-one, but is this a function? What's the vertical line test say? It's touching 1, 2, 3, 4 indefinitely many points if you go up and down like this, right? So this is not a function. We cannot test its one-to-oneness because it's not function at all. Okay? First thing you need to test is whether that thing is a function. Then we check one-to-oneness. If one of them is violated, we'd call it not one-to-one function. Okay? So that was a tricky one. Alright. Everything was smooth so far, so easy, piece of cake, because we were either given the table of values, you can plot those values, or you were given the graph. Now you are facing a roadblock, because I don't have either the graph to check whether this function is one-to-one, nor I don't have the table values of all x's and y's. Okay, one may say Oh, I know the graph of this thing. I can plot it, right? Everybody can plot this, right? What does this picture look like when you graph it? Is the parabola? What is it? It's a straight line. So you kind of have a feeling it's one-to-one or not, right? But no, let's not cheat. How do we prove that this is one-to-one? By only using the definition, because it says use the definition here only, not the graph or horizontal line test. Okay, here's the definition. We are using the right side form of proving something one-to-one. This, you will start with assuming this. You start with this given, and we need to obtain this result. So we always start with setting f of a equal f of b. In the final result, so you start with f of a equals f of b. You do some work here, and at the final stage here, I want to see you have proven with mathematical moves here of operations. I want to see on the very end you prove me A and B cannot be different. They are actually the same guys. Okay, that's one-to-oneness. If y values match, x values match. Alright, how do we do this? We need to fill in the blanks. So let me clean this up. We first assuming f of a equals f of b. But can you compute f of a? What is f of a? Oh, it's not f though. Our function is g. So can I call it g? Doesn't much matter. If you like, you can flip it to f, but we start with g of a equals g of b. All you need to do is compute g of a and compute g of b and set them equal. What is g of a? What is g of a? What would you do if I ask g of 3? Now it's asking g of a. Plug in a. Make every x a. Same way, make every x b. Alright, did we get the final result yet? No, I need to get rid of these 2's and everything. A and b. One side should have only a, nothing but only a. The other side should have only b, nothing but only b. Alright? Now how can I wipe off these 2's? What operation do we do? Subtract. We take away 2 from both sides. That's allowed in equation solving, right? Yes. So we have reduced our equation into this. Alright, I have minus 2's to be taken care of to get to this result. What do I do next? Divide. And voila, we have a equals b proven. Alright, that's it. You just say the conclusion here, g is one-to-one function. That's it. This is the proof. Okay? If you go all the way to the end with formal tools of math, correct tools of math, then you're done. You have proven it's one-to-one without any horizontal line test, any graphing. You've done it. But we have already knew this is a straight line, and straight lines can be only crossed once with horizontal line. We already knew it. It's one-to-one. We just proven it, right? Okay, how about number 7? By the way, how do we do this question in homework? Yeah, it's just true-false question. It is one-to-one. But again, don't just go trial error here. Okay? How about this one? First of all, what's your guts telling you? Is this one-to-one or not? Now, we know absolute values are V-shaped, V. And V's are crossed twice when you go with horizontals through them, right? So I have a feeling it's not one-to-one. So we won't be able to get a single A equals to B to the final result. Let's do it. You start with Ka equals Kb. You plug in A and B there, right? What is Ka? It is absolute A plus 3. What is Kb? It's absolute B plus 3. Now, this question belongs to solving. We've done a question like this in the past, solving absolute value equations. What section was it? In section 2 point something. If two absolute values set it into each other, how do we clear these absolute values? How? Okay, a simpler question. What if you had only this? How would you clear this absolute value around this A plus 3? If it was only set into 5. No, we cannot, because 3 is locked inside this prison walls. It won't let 3 escape. You cannot subtract 3 from there because you can't pass these walls. How do you break these walls first? Yeah, we remove those walls, once setting it into plus, once setting it into minus. It's the same deal here. You remove both of these walls, both once with a positive, both positive options, and once you put negative to a side of your choice. You can put the negative to the left or right. I prefer the right side, and I will put a minus before the entire thing. Okay, two options. Use originals, remove the absolute values, and use the opposite of one side, either side, left or right. Okay, let's go from here. Remember what we're trying to prove? We need to get A and B on their own on each side. So can I subtract 3's here? And we got A equals B here. How about this side? This is A plus 3 equals minus B minus 3, right? And I can isolate A by subtracting 3. However, things are not going smoothly this time. What did we get? A is alone finally. This is alone. Mission accomplished on this side. But did you get B all by itself? Without any numbers? It's minus 6 here. So this is the best I can do. A is either equal to B or A is something else. Equal to something else too. So A has two different values for a single Y. Like a single Y value, like this one, went to one A here and another A here, right? This is a single Y. Look, we started with a single Y. We set them equal, but ended up with two different A's. A is this value and then negative of that value and minus 6. So what is this proven to us? This function is K is not one-to-one. Okay? Again, one-to-oneness means this must be the only result you are getting. If you're getting another equation from this, that means you have a possible another A value, which is a violation to one-to-oneness. Okay? Does it make sense? Alright, this is a mathematical proof of K is not one-to-one. We already knew it from its graph. Okay, any questions before we go into the next stage? Alright, what we are going to do here is once you are given two separate functions, how do you test them? One of them is inverse of the other one. Such as, what is the definition of inverse in this picture? Conversion of currencies. You change dollars to euros and euros to dollars with two different formulas. And these functions are inverse of each other. And if you ask me, how do I know they are inverse of each other? Because I see each value is reversed on each computation. I feel they are inverse, but this is not the formal proof they are inverse of each other. I'm just convinced by four values. What happens if I have $500? Did you prove $500 are going to each other? No. Can we test all the single values one by one? No. We need a formal way to prove two functions are inverse of each other, a mathematical way, and it's this one. You compose those two functions, composition operation. Do you remember this from section 2.5? Composition of functions. You compose one into another and you flip the order and compose again. Are you getting only x? Yes, then it's called these functions are inverse of each other. Okay? So we are gonna just compose them. I will show you how. Alright, first one. Somebody is claiming these two functions are inverse of each other. I'm not buying it. I have to test it. Are they inverse of each other? You can test with values. You can send one into y and see if it comes back with this function to the same amount, like $100. Put $100, compute euros, and put the euros into this and see if you go back to $100. That kind of test. But that's just trial and error. We need to prove this by composition again. I first do 1 F circle G, but our letters change, H circle K. I will do H first. Let's do this. I will do H circle K of X and compute this. H circle K means, what does that mean? It means H is outside and you first send X into K. You send X into K and compute it, and there will be an outcome. That outcome will be sent to H and processed in H. So again, there are two combinations of machines here. The product X is sent into machine K. K is going to process it and then give some new material, and that new material will be sent to H. Okay? So let's process X in K, and they say what K does to X. If X is sent to K, X is turned into X plus 2 over 6. That's what I'm going to enter it here. Look, K of X is X plus 2 over 6. I'm just substituting here because that's what it says. X processed by this bus goes to this address. So I'm going to put down that address in the belly of H. The question in that one is easy. I just use the definition of Kx. This is inside is always you don't have to compute. You just borrow the description of that function and replace it here. The outside is tricky. This one is tricky. How do you process X plus 2 over 6 in H? We know how to process X only. X turns into 6 times X minus 2. So how do we process this? Any ideas? I wish this was only X. Then Hx will be, I would just put here 6x minus 2. If this was only X, green X under H, x under h goes 6x minus 2. But this is not x, something else. Then what do? X is gone. Take it away. X is gone. It's not there. You have something else. Then what do? Put that in. Yeah. Put it in right here, this thing, in place of x. Okay? Alright, look what's happening. Do you see something happening? What do you see? Madison? 6s are canceling. Alright, 6 canceled, but I still have some bunch of items. What else is happening? 2s are gone. Oh my god, look what happened. X rode on these two buses back to back and still on the same place. Like those buses undoed each other. Whatever the first bus took X to, H brought it back to same address. Like they are inverse of each other. They canceled out each other, right? Like you changed to euros and then went back to dollars again, right? This is what story, that exact same story telling me. You had $100, you still have $100 in your pocket. You first change the dollars and then exchange it again, okay? So this proves me that H and K are inverse of each other. H and K are inverses. Are you happy? Okay. Technically, I haven't done the all work. I should have also flipped the order and tested the reverse as well. So I rushed, and technically this is gonna wait a little bit more. We can't make the conclusion yet because I didn't check the second part. You should do the opposite order as well. K circle HX must be done as well. So this time K is outside, H is inside. I first substitute H in. This time H is 6x minus 2. 6x minus 2 is going in. And then I see what K does. K is x plus 2 over 6. It's x plus 2 over 6. But I don't have x inside anymore. I have something else. I put that in. Oh, these are canceling. I have 6x over 6. And those are canceling as well. You need to show both directions, okay? And you need to do this work as well. And I seen it's x and x in both cases. Then I can make the conclusion, okay? Unfortunately, both parts are required. Just proving the first one is not enough. But usually 99% of the time, if you prove one direction, the other one is also correct. Okay, so they are inverses. Again, don't just choose A and B and do trial and error here. Okay, 9. How about these two? Are they inverse of each other? The right side problem here. What's the verdict? Not 1 to 1? 1 to 1? I'm sorry, inverse. Are they inverses? How many of you guys say they are inverses? Not inverses? Everybody? Kyle, what do you think? 9. Inverse or not inverse? Not inverse. Okay, I'm going to take a shortcut here. I will only do the final part. Look, the shortcut version, what happened here is you take this formula and make every x on this formula this whole thing, right? That's what we did here actually. And for this part, we took the second formula and made every x this entire formula. So that's the shortcut test. I will take this second one and put it in every x and check the result is only x. Okay? So let's start. 4 plus, again, x is gone. 3x plus 4 came and replaced it. And this is 3x plus 8 because I have two like terms here. Over 3. And I can divide these, but I cannot divide that, so that's not a valid division. I need to divide both. I can separate these though. It's 3x over 3, and then I can separate these two at 8 over 3, and these two can cancel. What am I left with? Unfortunately, the result is not only x, but also something else. You didn't get only x like the left side, so not inverses. Okay? You don't have to test the other side. If one of them fails, you don't have to test the other side. But if you would want to go with the other test, you need to make each of these x's. This entire thing should replace each and every x here and compute it. And I think you will get this time x plus 8. The result will be x plus 8, but it is not necessary. Alright, here is one confusion. Once you prove two functions are inverse of each other, we don't use two different letters for them. Like we have proven h and k are inverse of each other, right? H and k. If you know one function is inverse of the other one, we use this notation, h on both. Whichever you like to call inverse, put this -1 on the right corner. This means inverse of h. When I see -1 on the right corner, it means inverse. Instead of using a different letter, we go with the same h. However, most people confuse this f to the -1 with this. It's not 1 over f. Like if I put 2 to the -1, you guys make this 1 over 2. But this -1 does not mean exponent. This is just notation. It's not power. It's not exponent. So this is totally false. When I ask what is V inverse here, people just put this whole thing under 1 because they think V inverse is the same as 1 over V, so they put 1 on the top, V on the bottom, and they give me, oh, here is the inverse of V. Absolutely ridiculous, okay? This -1 does not mean inverse, does not mean reciprocal power. It's not. It's just the notation. Maybe they should have used this letter instead of -1. They should have called it capital I. I as in the first letter of inverse. But it's a poor choice of notation, but we go with that. Again, don't make reciprocal when you see -1 in the right upper corner. Alright, here is, once you prove a function is 1-to-1, it has it has an inverse. These are the steps we need to follow to find inverse. For example, these functions were not inverse of each other. If you are wondering what the inverse of this function is, real inverse of this function is, you need to do these steps, and I'm going to show those steps on the following question. Okay? Did you know these steps before? Okay. All right, here is step 1. Replace the notation f of x by y. Where is my f of x notation? It's this one. I'm going to make it y first. That's step 1. It's a very simple step. Technically, it's just a flip of notation. V of x turn to y. Step 2. Interchange x and y. Interchange x and y. When I say interchange, this is what people do. They flip these sides and put x minus 2 on the left, and they flip just the sides. Okay, they put y on the left, ratio on the left, right. But no, that's not what I mean. We mean complete letter change. This y turns into x, and this x turns into y. Is it the only top x we change into y? No, the bottom as well. Each and every x needs to turn into y. So not the top only, but this bottom one too. Okay? Are we good so far? Now step 3 is the real main step. This is the most challenging part. The others are just phony steps. They are all easy, but step 3 requires some work. What do? You take this equation and solve for y, means isolate y. And that's a little bit problematic. Why? Because there are 2 y's on each side, one on the top, one on the bottom. There are 2. So you need to first bring them together, then isolate. Oh my god, the other y is on the denominator. How can I bring it back to the numerator with the other y? I need ideas. How do I bring this y to the top? Yeah. To bring a variable to numerator to the top, you need to get rid of that denominator by multiplying both sides with that exact denominator. And please, if that denominator consists of more than 1 items, like y and 7, 2 items, use them in parentheses and make a distribution multiplication, not straight multiplication. So again, these all cancel. That's why we are doing it. To cancel this denominator, we are doing that. This one is going to be y plus 7x. These canceled, and you have only y minus 2, right? Am I right? What's wrong? Yeah. You need to also multiply x and y too. Okay, what is our objective again? I'm lost. What are we trying to do?
Isolate y.
Okay, to isolate the y, I need to first bring all y's together, right? And I have y's on each side. So I need to bring one to the other side. So which one? Let's get rid of this one on the side. So what do? I subtract y from both sides. These y's come together now as xy minus y, 7x, so I'm just putting next to this guy, equals minus 2. Okay? Alright, next. I have them together, but I can't do any operation. I need to see a single y. This is double y. I have one something with y, something with y. I need to see single one. What can I do? Can I subtract these? No. I can't cancel these. This is x many y's and one y. I can't stand two separate y's. And besides, I want to see only y's here. I need to get rid of this 7x. So can I first get this 7x out of my way, like this? Now we are one step closer to the result, but I still have two double x's, two separate x's. I need to get them one. How? Divide by x, you mean both sides? Well, if I do that, these two cancel, but this one will have an x, y over x. And having a variable in the denominator is going back to this stage, and having a y, same thing. It's not advised. And still you will have y and y over x. Y minus y over x will be the result. You will still have two separate y's. I don't like two separate y's. I want single y. Dividing by x is not a good idea. More. Yeah. If you want to combine these y's and they're not subtracting, just factor y from that group. So if you borrow this y and this y out here, what is left in this first family? X. And this family, nothing, is just 0. When you factor everything out from a group of items, still there is a ghost 1. Alright? Okay, finally I have a single y, but it's not being completely isolated. There is a nasty stuff multiplying it. How can I get rid of this nasty stuff right beside my y? Divide it. Yes, if you don't like something multiplying to my variable, just divide it so you can wipe it off. Gone. Oh my god, we have now y completely alone. Isn't that amazing? Mission accomplished then. They want isolate y in step 3. Step 3 over. Step 4 is just a bogus step. What is step 4? Read it. Just says take that y away and make it f to the minus 1. Inverse notation. So you just make the left side this notation and mission accomplished. You have found the inverse of the function f, frame it. This is the result. Okay? Is the process clear? But it's very tricky process. There are so many traps waiting for you. If you don't practice on your own, you will fail, okay? You won't be able to get the right answer in one shot. Question was that. It's a fraction of minus 7x minus 2x minus 1. Good. Alright, we have one last question left, I think. And it's a very, very comprehensive question. Checks everything we know, okay? Alright, how many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9. I will do all these steps one by one, then go back and answer the question, okay? First off, graph x plus 2 under the square root. Okay, how do I do this? What section does this part belongs to? Is there a way to quickly graph square root of x plus 2? Is there a way to do that? Yeah, there is a way. I can just try to cheat here and try to guess the right answer. That's not the healthy way. We need to do this from scratch. On paper, how would you sketch x plus 2 under the square root? Come on. You've done this before. Ashley, do you know it?
Two and then the square root, things like that.
Okay, yeah. You first start with square root x. Does everybody know what square root x looks like? In 2.6, I ask you to memorize pictures of 7 main functions. This is one of them. This is it. This is square root x. This one is not root x. This one has a number added to it, and it's a shift. What kind of shift is that? It's a left shift, yes. It goes to minus 2, 0 instead of 0, 0. And it's a picture like this. And go pick that picture. Minus 2, 0, where are you? Here we go. It's C. This one is the right one. Next, from the graph of f, is f one-to-one function? Wipe off the green one. And tell me, is this red picture one-to-one? What test do you do here? Horizontal line test. I go through horizontal lines. Yep, I'm convinced it's one-to-one. Is one-to-one. Next, write the domain of f in interval notation. There are two ways to do that. Look at the graph, smash it to x-axis, really press it down to x-axis, check out the region showing up on x-axis, or you can actually, this is a very basic function, you can tell me what type of numbers you're allowed to enter into x, and it's going to turn into a computable square root. Can you describe me those numbers location? Addy? Yeah, anything more than negative 2. Shall we include negative 2 though? Yes, because negative 2 plus 2 is 0. Root 0 is computable. So again, when I press this down, the image I obtain is negative 2 and everything far right this way. So it is this point and further. It's negative 2 to infinity is the answer for part C. Again, I know that answer here. When I put negative 2, I'm good. But anything less, like negative 1, negative 5, negative 10, makes the inside of the square root undefined. So we need to avoid any less values than negative 2. So that means anything more than negative 2 is fine. Next, range. For range, you just need to compress this picture, smash it to y-axis, compress to y-axis. And what happens if you do that? What happens? Somebody read me that picture in interval notation. Yeah, it's 0 to everything up, 0 and everything up. All right. Okay, 0 to infinity, I can type it in here. Is 0 included though? Or parentheses? It's included, so go with 0 bracket and infinity. Okay, we're back. Again, when I compress this, this is the picture I obtained. We always read y-axis from bottom to top. First one I see is 0. The last one I see infinity. Okay. Alright, we need to compute inverse of this function because it's one-to-one. I can find it inverse. How do I know I can find it? Because I know it's one-to-one. Anything one-to-one can be found in inverse. So you guys need to invert this in part E. And we're gonna do this 4-step method here. We did. Step 1, I change f into y. Step 2, I interchange x and y. I'm doing this kind of quick. Let me know if you miss a spot. Step 3, the main step, so slow down and think carefully. Main step now. So this is 1, this is 2, 3. We are going to isolate, get y by itself. So you guys need to focus on this side. Y is there. I need to get rid of this guy, square root. I need to get rid of 2 and get y isolated. How do I get rid of, which one is first? Square root, because 2 is inside the square root. It cannot be faced with quickly. We need to first pass an obstacle of square root. So I need to get rid of that square root. How? What's the right weapon to remove absolute value? How do you wipe off of an absolute value? Yeah, we put square on both sides. So it will get x squared on the left, and this square root and square cancels out. Do we need a plus and minus somewhere? No, we do that when you're taking square root, we put plus and minus, but when you're squaring it, you're safe, okay? Alright, next. Get rid of that 2 and you're all set. Well, we got y on the right, we like to have y on the left, so can I flip the both sides and say y equals x squared minus 2? Yeah, without any change, you can flip both sides of an equation. This is step 3, but step 4 is formula declaring the inverse. So make y into this, and voila. This is the inverse. Okay. Alright. Now, when you go to question, try to enter that. There is a second part. I will talk about this, but let me first key this in here. Now what's going on here? What the heck this means? It says I need to pick an inequality and put a number here. Here is what's going on. Sometimes when you invert a function, look, inverse of this function is you get more than what you want because you did something artificial. We squared here, remember both sides? Look, what happens when I square x minus 2? Shall we square both sides? X equal 2. I'm squaring both sides. Do you mind? Okay. Now I have x squared equal 4. Oh, I changed my mind. I want to go back to x again. I take square root of both sides. Oh my god, something happens. When I take square root of both sides, instead of going directly back to 2, I have now two numbers, plus and minus 2. So kinda when you square an equation, it's not a safe operation. Squaring doubles your answers. It drastically changes your equation. It's no longer the natural equation. So when I square this result may have some extra pieces, undesired pieces like this. I may have duplicated something, double result. I have to trim the excess, undesired result, because when you graph x squared minus 2, x squared is this thing. Minus 2 means down 2. Down 2 is this. Inverse of a function, first of all, should be 1 to 1, and this function is not 1 to 1. Okay? So I need to take only one part of this graph so it can be 1 to 1. Which part I'm going to take? Because of the squaring, I created two branches. I need to take only one branch off of this thing. Which part do you think I'm going to take? Here is the answer to this question. This is a very good question. Checks everything we know. Remember this one? What's the relation between an original function and its inverse? They are symmetric to each other. Don't we have the graph of the function already built for us in part A? This. So all you need to do is check out the inverse of this function, find the inverse graph by simply taking symmetry of this function. So again, here's your original. I want you to take symmetry of this red picture according to this dashed line. So this dot is going to move into here. Okay, this dot is going to move into here. This dot is already on the line. This one, so it will stay on the line. This one will go here. This one will go here. So connect those green dots. Oh my god. It tells you this is F inverse. It tells me which part of this parabola we are gonna take. Which half are we gonna take? The right side, not the left one. So we need to describe here what x values, for x values, do you get on this side? These are x values. For x what? How do you describe this right side of x values? For x, this is the positive x values, right? We need to put this here. You need to consider F inverse. It cannot be not 1 to 1 whole parabola. It should be one piece of the parabola. It is the part x greater than 0. Right? This is 0 or more. If it was the left side, I will take x less than, just strictly less than 0. But it's not the case. Make sense? Okay. So we are going to go here and say we're only going to consider x values more than or equal to 0. Alright, next. Explain why the restriction is placed on F inverse. I kinda explained it. The restriction x greater than 0 on F is necessary because F has the restriction that, look, F, what is F? Our original F. This graph, red one. What kind of y values do you see there? Clean this up. Remember, inverting a function means making y values into x. So this function has y values. Look, when you compress this red picture into y, it has y values more than 0. So when I flip this, get inverse of this function, these y values turn into x values. That's why this graph had x values positive, because original function, red one, has y values positive. Okay? So this is the explanation. F of x, or y values, were greater than 0. That's why we took x values to be 0. If the question was, I double clicked it. If the question had a minus here, we would pick this function and y value would be negative. We would go with the negative side and negative x values if it was a negative. So earlier part was right. In number 7, you need to pick the correct graph for F inverse. We already did that. Which one was it? This is the original, this is the inverse. So it's D, correct? F and F inverse, you see the symmetry? If you go through a line between them, these two pictures are symmetric. So it's D. And finally, write the domain of F inverse in interval notation. Again, you can determine F inverse notation. This is F inverse. Its domain is, that green line has domain as, its domain is this, right? Just press it down to x-axis. This is F inverse. Its domain is this guy. Or range of, we have found the range of F, right? Range of F is the domain of F inverse, actually, because range and domain flipped when you get inverse. So you could cheat from part D. Whatever the number you put for range of F, it's going to be domain, it's going to be domain of F inverse. Whatever domain you pick for F, it's going to be for range of F inverse. So you can, it's just asking for part C and D again here. So domain of F was all values more than 0, right? And range is the same as well. Range is the domain of F. Domain of F is, no, it was -2, right? Domain of F was -2 to infinity. Or you can check here directly from the picture. The range of green dot is, this is the range, -2 to infinity. It's not 0. I really like this question, right? It checked everything we know about inverse functions, their graphs, and their relation between domain and range. You also find F inverse. Very comprehensive question. Please take your time on this question and practice. Once you solve this, hit the practice button and try another button if you want. Solve another one until you feel comfortable, really everything settles down, okay?